All right, this lesson is going to be very quick. It's just going to be extra practice finding sine and cosine values from the unit circle, which you've already done during the unit circle lesson. All right, so just bear with me. This is going to go quickly. I just want to make sure you all understand how this works, okay? So for sine and cosine function values, remember we are no longer talking about triangle ratios. We're now talking about distances on a graph, and we use circles to help us do that. So right here I have a 45, 45, 90-degree triangle in terms of pi radians. So I no longer am marking these angles here and here in degrees. I'm marking them in radians. So first thing that should tell you is pi over 4 radians is the same as 45 degrees. Okay? And we actually already solved in another video um, what the ratios of each of these sides are, or sorry, the lengths of each of these sides are. Um, what we did is we based it on a hypotenuse of 1. And then if you remember, each of these sides was 1 over root 2, I believe. In this case, this is just another way to look at it. So this is if the hypotenuse is root 2, each of these sides is 1, all right? Which tells us, if I look at any of these angles and I take the sine value, remember sine is opposite over hypotenuse. Okay, I can start on any angle, go to the opposite side. It's 1 over the hypotenuse is root 2. And we, of course, don't leave our radicals in the denominator, so we would write this as root 2 over 2. Just like that. Okay? For cosine of pi over 4, the nice thing about a 45, 45, 90 triangle is for cosine, this is going to be the exact same because the opposite and adjacent sides are the same length. So what that tells you, and what you've hopefully already noticed about the unit circle, is that for every pi over 4 radians, in other words, for every 45 degrees, okay, um, the positive y, the negative y, and the negative x, positive x, those are the easy coordinates, right? So if I'm going this way, my coordinates are 1, comma 0. If I'm going straight up, you guys know they're 0, comma 1. Straight back is negative 1, comma 0. And straight down is 0, comma negative 1. Those are the easy ones. But for the angled ones, so all these 45-degree offsets, all the coordinates are going to be exactly the same because the cosine and the sine values are exactly the same. So remember, cosine is the x coordinate, sine is the y coordinate, and in this case, they're both equal to each other. So I should be able to, the first thing that you do on your unit circle, and honestly, the first thing that I still do on my unit circle whenever I have to remember it, is I just immediately do the 45-degree ones because they're all going to be the exact same. Minus the signs, right? Like you have to pay attention to which coordinates are negative and which ones are positive. But other than that, the actual value is all the same. Okay, so once again, just as a reminder, in quadrant 1, both x and y are positive. In quadrant 2, x is negative. In quadrant 3, they're both negative. And in quadrant 4, y is negative. Okay. All right, now, down here, what you need to be able to do, and what you honestly need to be able to do is, without looking at the unit circle, you want to try and be able to memorize what all of these values are. All right, I will show you how to do the first one and then I'll give you all the answers. But the way this works is the sine of pi over 4. If you have your unit circle memorized, you should know that when you go to pi over 4 radians and you look at these coordinates, the y-coordinate is the sine value. So if you're asked what the sine of pi over 4 is, that is root 2 over 2. Okay? So I can write that in here. Oops, wrong tool. And what I should be able to do is go through each of these, all right, and do that same thing. Figure out what the value is for them, all right? So I'm going to pause the video. I'm going to let you do that, and I will give you the answer in 3, 2, 1. All right, so hopefully you noticed that each of these are some version of pi over 4, except for this one. We'll talk about that in a sec. But anytime you have pi over 4, that's one of those 45-degree offsets. So you should have either a positive or a negative version of root 2 over 2 in most of these. Sine of pi, remember pi is exactly halfway around the circle. Okay? And we know that the coordinate point halfway for the y value is 0. Okay? Now, the other thing I want to point out is these negative ones. So hopefully you figured it out by now, but in case you haven't, a negative angle, remember from one of the previous lessons, goes the opposite direction. So if I say sine of negative 3 pi over 4, that means I'm actually going this way around the circle, clockwise, and 1, 2, 3 pi over 4, that's right here, okay? That is the same as positive 1, 2, 3, 4, 5 pi over 4. So just for your reference, sine of negative 3 pi over 4, well, that's the same as the sine of positive 5 pi over 4. And there's a little trick to that. Ignoring the negative for a sec, if you want to find the positive version of a negative angle, you just ignore the negative and you add to this 3 pi until you get something that equals 2. So I know 8 pi over 4 is going to give me 2 pi. So I need to add 5 more pi to 3 pi in order to get 8 pi, all right? If I were to add these two up, I would get 2 pi, which completes the circle. So same thing here. If I ignore the negative, I need to figure out what do I add to 7 pi over 4 to make a full 2 pi circle. That is 1 pi over 4. Okay? So negative 7 pi over 4, that's the same as pi over 4. Okay, very good. Now, you can do the same thing for sine values, all right? Or excuse me, not sine values. Sine and cosine values for the 30, 60, 90 degree triangle, okay? 60 degrees, that's going to be pi over 3 radians. 30 degrees, that's going to be pi over 6. And we've got these side lengths here to kind of help us out. So if I'm looking at the sine of pi over 6, remember I'm going to start on this angle. I'm going to look opposite over hypotenuse. So this is 1 over 2. All right, go ahead and see if you can fill out the rest of these three. Remember, cosine is adjacent over hypotenuse. And I will give you the answer in 3, 2, 1. Okay, so hopefully you had these ratios set up. And I went ahead and labeled these two as the 30-degree locations and these two as the 60-degree locations. Because I want you to notice that the cosine of 30 degrees is the same as the sine of 60 degrees. These two are always going to be the same. And then vice versa for sine, right? The sine of 30 degrees is always equal to the cosine of 60 degrees. Those two are always going to be the same. And what that tells you on the unit circle is that every time we switch back and forth from 30 degrees right here to 60 degrees right here, the coordinates are just going to switch spots. Okay? So once again, starting at pi over 6, I know my cosine, my x-coordinate, is root 3 over 2, and my y-coordinate is 1/2. So I'm going to go ahead and fill that in. Root 3 over 2, comma, 1/2. But then when I get to 30 degrees, or sorry, 60 degrees, We just discussed that these two are just going to switch spots like that. Okay. And then when I go over here, uh, this one is straight across from the 60-degree location or the pi over 3 location. And so these coordinates are going to be the exact same. Just got to pay attention to your negatives. Right? And once I'm down here, these are across from each other. So these are going to be the same. You just have to pay attention to your negatives. All right? Go ahead and fill out the bottom part of the circle. I will give you the answer in 3, 2, 1. All right, so the way you go about this is whatever point you left off on, you just go straight across or straight down, and it should be the same values. Just pay attention to your negatives. So then this one should go straight down to this one, change the signs that you need to. And then these two need to just go straight across. Very good. Okay, last, same deal. You should be able to, without looking at the unit circle, just figure out what all of these values should be, all right? So once again, if I'm looking at this, cosine of pi over 3, I would go to the pi over 3 spot, all right? That would be this spot right here. I'm talking about cosine, so that's my x-coordinate. And I now know the cosine of pi over 3 is 1/2. So if I was asked, find the cosine of pi over 3, I would say that equals 1/2. So once again, I want you to go ahead and pause the video, try these on your own. You will have the answers in 3, 2, 1. All right, here are the answers to those. Be careful with number 11. Remember, negative pi over 2. That's the same as going pi over 2 radians, but backwards. So that's right here. It's the same as positive 3 pi over 2. And the cosine, or the x-coordinate along this line, is just 0. Okay, now I'm going to end the lesson here. What I want you guys to do is look at this final page of your notes, all right? It's got some tips and tricks on it uh, so that if you have struggled to memorize the unit circle, here's some like patterns to help you out. I want you to just look over those, maybe fill this one out using the patterns that they tell you. But that's it for this lesson.